And we're live. Welcome to the CoprHD community webcast. We're going to have a special announcement here for in a second. And so let us get started. My name is John Mark Walker. I'm Director of Product Management for Viper Controller and CoprHD. And I've got with me Evgeny Reutman and Satish Sampath. And we're going to talk to you about some announcements we've made, some other stuff. Let me get this started. Okay, and let's get started. Oh, no, that's the wrong one. Sorry, wrong. Yeah. There we go. Wrong slide deck. Okay, that's the one. All right, so we wanted to get started with a couple of things today. So you may have seen the press release yesterday, wherein we announced that we, as part of the CoprHD project and from Dell EMC, have decided to contribute the the CoprHD southbound storage SDK to the Linux Foundation, and we're joining the OpenSDS project and community. And what we're going to do is we're going to give you a little bit of context around that announcement. What is CoprHD? Why did we decide to do this? And what are we doing with the OpenSDS? And then the principal architect behind the storage SDK will kind of walk you through what it is, how to use it, and how to build drivers for it. Right now, the storage SDK is designed for block storage, for creating interoperable drivers for block storage arrays. But over the next year, we're going to be adding support for file systems, object storage, to make it a comprehensive driver SDK for all kinds of storage platforms. You can follow along on the Slack channel at opensds.slack.com. That's the OpenSDS channel where you'll find other members of the OpenSDS community. And without further ado, let's get started. So here's what we announced when there was a press release yesterday that came out from the Linux Foundation where we talked about OpenSDS and how we were joining and what we were contributing. And what OpenSDS is, it's a community of storage vendors and customers. And we're all dedicated to the concept of storage interoperability and creating a set of software that lets everyone kind of share and collaborate on storage interoperability. That can go from the interfaces, wherein the storage SDK fills a gap, as well as the kind of controller technology that sits above that. Right now, we have an open source storage controller called CoprHD. And there are plans to, what OpenSDS wants to do is take existing technologies and use them together in kind of a best of breed approach to determine how best to create this solution, open source solution that fits the bill for enterprise customers. There are other storage controllers out there, open source storage controllers, of which Sender is probably the most notable. There's also Rexray and a few others. But when it comes to kind of enterprise storage, we feel that this SDK and CoprHD are kind of the best approach towards storage interoperability for enterprise storage devices. And while the storage SDK at this point is CoprHD or Viper Controller specific, we would like to see other implementations or others take this implementation and apply it to other controllers as well, so that you can build drivers with the kind of enterprise class functionality that's available to everyone, not just the CoprHD community. So we've pushed the first check-in of the storage SDK into GitHub under the OpenSDS GitHub account. You can find that in the link here on this page on GitHub. This will be the upstream location where this storage SDK will be developed. You'll see roadmaps posted here, along with any other kind of usability information. There are some links now that take you to a programmer's guide, some other information you can use to get started with building and testing drivers. And beginning in a minute here, we'll walk through what you have to do to actually build and support a driver. So again, the name of the game here is about storage interoperability, getting kind of our customers and other vendors and partners involved in driving this community forward and making sure that we can all participate and sort of produce things that are greater than the sum of our parts. I can tell you that our customers have been very forceful in asking for better storage interoperability, and that's one of the reasons that we open sourced CoprHD in the first place. When we took Viper Controller and formed the open source CoprHD community, it was in direct response to our working with customers and trying to address some of the day-to-day problems they have with storage management and storage interoperability. So this is kind of a stake in the ground so that we can collaborate in this area and produce something that is useful for others who have to manage storage on a daily basis. It's also an attempt to kind of push forward, and all the other layers of the stack have been moving towards this open source interoperable model. Obviously, we in the OpenSDS community, we see the same trends that affect everyone else, and so this is an attempt to meet our customers on the level playing field that they're striving towards, and just making sure that we can all work together in some sort of coherent fashion. So,
I don't think you're sharing anything.
Oh, really?
I can hear you. But...
So I'm just getting reports that it's not being shared. Hang on a second. Can you see it now?
It's still on the way.
Okay, 1 second. Oh, there we go. My apologies. Minor technical difficulty. Now it's being presented. Yeah. So I was talking, and no one knew what I was talking over. So this is the slide deck. So I'm just going to go back into presentation mode, and there we go. All right. So as I mentioned when I talked about this slide a minute ago, I went through the Slack link, the GitHub link, and it still don't work. And yeah, so this is okay. So I guess the key here is not to go into presentation mode. So I went through the GitHub link, the Slack channel link, talking about why what the OpenSDS is and what the storage SDK is, and why we did that. So let's get on to kind of what the vision is going forward, and why we're and what we hope to achieve. If you look at CoprHD, and if you look at the point of CoprHD, we see kind of the storage controller fitting kind of in the middle. If you look at the existing infrastructure as it exists today, the storage controller fitting in the middle between kind of all the orchestration and cloud services running in the northbound side, and then all the sorts of storage sitting on the southbound side. Obviously, because CoprHD comes from Dell EMC, we've written a lot of EMC drivers. I'm also happy to report that there are efforts have been made to create drivers for example, HPE 3PAR, other drivers as well that are that we're just now starting, including an SVC and an XIB driver. So we'll continue on that front. And now that we have the storage SDK in the open and under the Linux Foundation, OpenSDS, we really want to encourage collaboration and interoperability. So now that I've set the stage for what we're doing and why, I'm going to turn over to the principal architect behind the storage SDK, Evgeny Reitman, and he's going to step through kind of the code base and what it can do. Yeah, go ahead.
Hello, my name is Evgeny Roitman, and as John Mark said, I'm primary architect of this southbound storage driver SDK. So I go over several slides to describe what is inside, what is design principle for southbound storage driver SDK and what is inside the driver. So primary goal was to abstract driver SDK, the driver API from Viper controller. So to eliminate any code dependency between driver code and Viper controller code. So that's we created southbound SDK, which is decoupled from Viper controller. So developers which know their physical domain will just need to know their physical domain and need to look in to look in the SDK and see how API defines primary storage kind of interface for their physical storage array. So no need to learn anything about CoprHD. CoprHD Viper, just understand SDK, know their physical domain and write storage driver. So this is a simple way to integrate support for new storage arrays into CoprHD Viper. So driver SDK introduced a way to develop, build, and test drivers independently from Viper. All array-specific features are handled inside storage driver code, and also we will provide support for automated storage driver installation into Viper at runtime. So driver can be developed, built, tested independently, then installed into Viper, go through integration testing, and be ready for production. So I go over design points. I mentioned several of them earlier, but that's kind of formal design point list. So standalone storage driver SDK independent from Viper controller or specific features of storage arrays. Storage drivers for new arrays can be developed, built, and tested independently from Viper. The only compile time dependency from Viper for storage drivers is southbound SDK library. And also we provide convenience services to drivers. So we provide APIs for registry and local manager. Drivers can use these services. And also we will provide dynamic runtime installation of storage drivers into existing Viper cluster. So that's primary design points. So what is inside southbound SDK? So currently we have SDK for block storage provisioning. So we have support for discovery. We can discover storage system, pools, ports, support for major storage provisioning operations like create volume, expand, delete volume, export volume to host cluster. Also support for snapshots, local clones, and ingestion. So driver SDK also has object model. So it's independent SDK specific object model, and this is how CoprHD communicates with drivers through API. So main storage classes are in the object model, like storage system, storage pool, storage port, volume, snapshot, and other types. As I said, interfaces for Viper provided services, registry and log manager interfaces are in SDK. Also, base class is abstract storage driver, and we publish driver code and compiled jar, which each release to the provided link here. Now I mentioned earlier, but this is a specific set of features which we support for X-Wing release. So discovery of your storage domain, volume provisioning operations, export volumes to host clusters, consistency group operations support, local protection operations for volumes and consistency groups, export operations for volume snapshots and for volume snapshots and clones, and also ingestion. So we ingest through southbound SDK, we can ingest volume snaps, clones with exports and without exports. Driver development and installation. So we have main wiki page here, which describes how to develop driver and how to install it in CoprHD. Just driver should follow interfaces defined in SDK, and SDK has very specific Java doc, which defines how, like, what is expected from parameters passed to SDK methods and what is expected from parameters which are marked as output parameters, which driver sends back to CoprHD. Driver installation for X-Wing, it's kind of manual process. So it's basically you develop driver, build jar file, and then and then you take this jar file. You need to modify several XML files in Viper to add new driver to specific driver maps. And after that, you put your jar file on controller on class path of controller service, restart Viper services, and driver will be consumed by CoprHD. This process will be automated for next Anakin release. So we will provide specific user interface support for this. So developer will need to define some metadata about their drivers, which will be part of the driver jar file, and then through dedicated user interface screens define driver type, driver name, point to the driver jar file, and Viper will read this information and install driver automatically and make it available for, like, on the same level as all other native storage drivers. New features which come with Anakin release is provisioning of remote replicated volumes and remote replication link management operations. So this is when say customer wants to create remotely protected volume on two sides, source and target, and then use remote link operations to failover, failback, and other management operation for link management. So this is expected in the next release. So that's primarily all I have for this slide deck.
Oh.
Now I can try to show
Sure.
code.
All right. Let's go to.
1 second.
We're gonna go to. And you get the multi-layered specialness there as we and okay, do you want to step there?
So I can describe what is inside GitHub repository. So this is storage SDK repository. There are the directory for existing drivers, which already exist, and developers may use them as a reference drivers. And also Java SDK contains all SDK code. So this is package where all SDK code exists. Now, in this main directory, storage drivers, their main APIs, discovery driver, as I said, is API for discovery. Block storage driver is API for block storage provisioning. And then there's base class abstract storage driver and some like default storage driver, which based on the abstract storage driver, which provides default implementation of all SDK methods. So developers may go and implement, extend abstract storage driver and add methods as they go. So and then compile. So default storage driver will provide will protect from compilation errors if you don't implement all methods at once. So interfaces for log manager, which is what CoprHD provides to drivers, and registry. In the model folder, there are model classes, and these model classes are used to in SDK method to communicate information from CoprHD to driver and from driver to CoprHD. Let's try to look inside, say, block storage driver. So as I said, each method has detailed Java doc description describing purpose and input and output parameters. And typically all methods which do some kind of provisioning, they all return driver task. So driver task is primarily how CoprHD knows outcome of SDK call to driver. If we look in this method, create volumes, so we see that it has a list of storage volumes which are sent to driver to create, and then storage capabilities. So this first parameter, volumes, it's input-output parameter. So what does it mean? It means that part of the properties are used to let know driver how to create volume, what kind of type of volume it should be, thin or thick, what capacity should be. And then when driver creates volume, driver should set some other parameters inside storage volumes to indicate what is native ID of the created driver, for example. Storage capabilities parameter is used to pass array-specific capabilities for volume. For example, it could be array-specific tier, storage tier for volume, or some other capabilities. I will show what we have right now, but this is primarily how we plan to consume array-specific features without modifying API. Because let's say today we have set of drivers, and tomorrow there's a new driver for new storage array which has unique capabilities, and these capabilities are important for say create volumes. So that's how we don't want to modify storage volume type to include them. Instead, we provide them as a storage capability, as a list of storage capabilities. So driver understand them, and CoprHD use them in kind of opaque pass-through mode. So there are also a set of get methods, all methods which start from get, like get volume snapshots. Let's look here, get storage volumes, and then get volume snapshots, get volume clones. All this and other methods which starts from with get, they are intended for ingestion. So it's the way we question storage driver to ask what resources already are there on array, like what volumes, what clones, what snapshots, what you can see below mirrors, and then there are also the same type of get methods for exports. So we question driver what resources are there, and then kind of process them and ingest, and user may ingest them into CoprHD. So that's a primary class which describes SDK methods. I can go back and go to storage capabilities. As I mentioned, that we have almost all SDK methods has parameter to pass storage capabilities. So what are capabilities? This, as I said, some unique unique features of arrays. And currently we have auto-tiering policy capability and also deduplication capability. So one deduplication capability is applicable for HP3 par array. Auto-tiering policy is applicable again for HP3 par array. You can read about capability model on the web pages, which mentioned on in slides. Okay. That's all I have.
Okay.
For now.
Cool.
If any questions.
All right.
So I'll give it back to John.
All right. Thanks, Evgeny. Just to kind of go through the different resources we have if you want to learn more. We have the, if I go back to the README file on the base of the repository, there's the, this has a bunch of links in the README file to either the latest releases that you can start with if you want to try out new drivers. There's a couple of links to kind of how-to articles, and then we have a developer's guide that's included in the repository, and I can actually show you the page where that's live. This is the wiki where you can find the programmer's guide. It gives a lot of stuff about, you know, what are the underpinnings of the driver. Again, and we get into a lot more detail when we talk about the SDK for array integration. So there's a lot of significant content here for you to browse through, and that should give you a lot of places to get started, including, in fact, some jar files that you can actually look at here that as part of the attachments for the last page I was looking at. If you want these links, I'll make sure to update the README to have all of these links so that you can find them and so that they're available. But otherwise, you know, this is, like I said, this is the current implementation. It is a Java SDK. We would love to get, you know, the OpenSDS group would love to get contributions in the form of, you know, different language bindings, different implementations for different controllers. It would be great to get something that, you know, so that in the very near future, anyone can count on a certain number of kind of like a baseline of features to be expected in storage drivers for a modern software-defined storage controller. That's the ultimate goal. So I hope you enjoyed the presentation. We look forward to working with the other members of OpenSDS and the Linux Foundation. We want to thank the Linux Foundation for their support. I want to thank all the other participants that have been, we've been talking and working towards this for a long time. And so now that we have this structure to work under, I'm hoping that it will go much more quickly and we'll be able to produce a lot more output. This is just the start. This is just a beginning. The SDK is here. It's something you can build on. And then I know that there are active discussions right now around what is the next piece of the puzzle. There's a lot of talk around producing some work on top of things like OpenStack Cinder or even CoprHD or any other kind of open source controller. So like I said before, to create kind of a best of breed approach and a multi-implementation approach so that it's really up to the end user or developer what they want to use. But ultimately, let's decide on what interoperability looks like, and let's make it easier for us to use it. Thanks. Thanks everybody for stopping by. So I'll go ahead and close this up for now, and then we will, and then we'll have the recording available here. And look for more. Go to the Slack channel. Look for more announcements there about where we go from here. Thanks, everybody. Stop. Okay. All right.
Awesome.